Okay, so we've moved into chapter 7. We're still dealing with polynomials. Now we are looking at multiplying and dividing polynomials. So keeping in mind our exponent rules when we are multiplying and dividing polynomials, and keeping in mind our like terms and all that kind of stuff. So we're gonna start with multiplying, and we will move to dividing in later lessons. So in order to multiply, sometimes we want to use algebra tiles, and we want to use the area model. Method, okay? So what that means is we're thinking of two monomials that are being multiplied as the length and width of a rectangle, and we're looking for the area. So when we look at our first example, 3x and then 3x, so remembering that if there's nothing written in between, if two things are side by side like that, especially with brackets, two terms side by side, they're being multiplied. So this is 3x times 3x. So that means we have one length of 3x, so length of x, a length of x, a length of x, so 3x altogether. Okay, and so then we need to think, well, what kind of tiles are made when you have a length of x and a width of x? And a length of x and a width of x makes a x squared tile. And so then if we look again, a length of x and a width of x, that makes another x squared tile. Okay, so then we end up with a bunch of x squareds, and if we add them all up, we get an area of 9x squared. So 3x times 3x equals 9x squared. Taking a look at the second one, so in this one we have a length 2x, so if we're thinking length times width or base times height, we have a length of 2x. And a width of 5x. And so again, every time we're just going to multiply, and so if we have a length of x and a width of x, we get x squared, x squared, okay, so those are all x squareds, and we end up with 10x squared, so that's our area, 10x squared. So 2x times 5x gives us 10x squared. Okay, so we're going to try these two again. And keep in mind that product, when it says determine the product is the answer of multiplication. So again, we're thinking base times height or length times width. So I want you to give that one a try on your own. And we're going to try this one together. Okay, because it's a little bit different. So we have 3 positive x for the base. So 1, 2, 3. And then for the height, pardon me, we have negative 2x. So now we're thinking as base times height get multiplied, we get positive x times negative x. Well, if we keep in mind our sign rules for multiplying, opposite signs make a negative, so positive times a negative gives us a negative x squared. Positive times a negative gives us negative x squared. Positive times a negative gives us negative x squared. Negative x squared. Negative x squared. Basically, all end up being negative x squared. Combine our like terms, add the shapes together together that are the same. We have 6 of the same shape, and we have 6 negative x squared. So 3x times negative 2x gives us negative 6x squared. And again, you're going to check this one on your own, and we're going to double check it together tomorrow. Okay, so next thing. Oh, there we go. Okay. So the second way we can do this is numerically. So drawing it out is great and fun, and building it is sometimes a lot easier to see. But some people want to move to a more efficient method or a quicker method. And so, of course, the quicker method is straight multiplying. And so we're going to do this numerically. And so the way that we do this numerically is we're going to take coefficient, and we're going to times it by the other coefficient. Okay, so that's like thinking numbers times numbers. A number times number. Probably should be singular. So we're going to multiply the number with the other number, and then we're going to multiply variable and variable. And it could be multiple variables. So variable or variables times variable. So numbers with numbers, letters with letters. Okay? The other thing that I want you to keep in mind is that if we did something like this, so if we said 2 times 3 times 1, well, 2 times 3 is 6, times 1 is 6. Okay? If we change the order that we multiply it, so let's go 1 times 2 times 3. So 1 times 2 is 2, 2 times 3 is 6. So when we multiply, the order that we multiply the factors does not matter. It does not impact our solution. And so we want to kind of keep that in mind. You might want to write that down. So the order that factors are multiplied does not impact the solution. Okay, it doesn't impact your product. So keeping in mind numbers with numbers and variables with variables, we're going to rewrite this. So right now we have 2 times x times 6 times x. So we're going to reorder it so that the numbers are being multiplied with the numbers and the variables are being multiplied with the variables. So we're going to have 2 times 6 times x times x. Again, I might recommend using some kind of color coding or check mark system or something, so that way you remember to use all of your terms, that you don't accidentally forget something or use something more than once. So if we're multiplying our coefficients, 2 times 6, that gives us 12. And when we are multiplying our variables, if you keep in mind your exponent laws, if we have the same base, so same base with exponents, remember if there's no number there, it's a 1. Same base being multiplied, we add the exponent. So this is x to the power of 1 plus 1. So we end up with 12 times x to the power of 2, or 12x squared. And so we end up with one monomial in the end. Okay? Taking a look at our second example, we're going to do the same thing. So we start with 4 times x times 3 times y. We're going to rearrange so that way our like terms are together. I don't know if you guys can hear it, but there's a really loud helicopter going overhead right now. So if you did something bad in the neighborhood, they're looking for you. By the time you get this warning, it's probably too late. So sorry. Okay, and then we're going to do variables with variables. So when we multiply, 4 times 3, again, that gives us 12. And x times y, they are not the same base, so we can't use our exponent laws, so they just stay in alphabetical order, so 12 times xy, or 12 times x times y. Okay, give a couple more of these a go. Yes, there are a lot here. No, I'm not going to do all of them for you. Take a look at C. So we've got, I'm going to keep these in brackets just to keep the negative sign with the proper integer. So negative 7 times y times negative 2 times x. So if we reorder it, so that way numbers with numbers, variables with variables, negative 7 times negative 2 times y times x. So keeping in mind our integer rules, negative times a negative gives us a positive 14. Y times x, not the same base, so we can't add the exponent, so it just stays as yx. And so we switch it to xy, 14xy. We always want to keep it standard form alphabetical. D, I'm going to have you try D by yourself. I'm going to have you try E by yourself. And I'm going to have you try F by yourself. Okay, I will show you G and H. For G, we have negative n. So right now it doesn't look like there's a coefficient on the n, but it's actually a negative 1n times 7.5 times n. So split it again, negative 1 times n times 7.5 times n. I didn't really need the brackets on this term. Okay, so numbers with numbers, variables with variables, so negative 1 times 7.5 times n. So numbers with numbers, negative 1 times 7.5 becomes negative 7.5. N times n, they are the same base. They each have an exponent of 1, so that becomes n to the power of 2. So together it makes negative 7.5 n squared. Looking at h. So for h, we have 1/3 x times 3x. So 1/3 times x times 3 times x. So 1/3 times 3 times x times x. So I skipped out that second step, okay? Or sorry, the first step. I went straight to the second step. I didn't reorder them right away. If you're starting to become more efficient in work, you can start cutting out a few of these little steps. But I would like you still grouping your coefficients and your variables together. So 1/3 times 3, we're thinking of it like 3/1. That ends up giving us 3/3, right? 1 numerator times numerator, denominator times denominator, times x times x. 3/3, that's just 1. And x times x, same base, we can add the exponents, so 1x squared. So we could just say x squared or 1x squared. There. Or either of those will work. So I am going to check those examples from you tomorrow, so please make sure you have given them a try on your own. I don't want you just showing up and say, I didn't get it. I want you to actually give them a try. I would much rather see you do them wrong, and then we have to go back and fix them, than to see them blank tomorrow.